Hello, good day viewers, welcome back once again. Today we're going to find the following given limits. We have limit as n is approaching infinity of n factorial divided by n to the power of n, all raised to the power of 1 over n. Now the reason why I put this down right over here is because I have made video about this limit. The limit as x is approaching infinity of x to the power of 1 over x is equal to 1. If you check the comment section, the link of this video will be there. So you can follow the link and watch how this limit evaluates to 1. Right? The reason why I put it down here is because this is going to be very helpful in this video. Now let's get into the video. Now in this video, I'll be making use of the Sterling approximation for n factorial. The Sterling approximation for n factorial is roughly approximated to n to the power of n times e to the power of negative n multiplied by square root of 2n pi. Right? Now, the given limit as n is approaching infinity of n factorial divided by n to the power of n, all raised to the power of 1 over n, we're going to make use of the Sterling approximation. So here we have limit as n is approaching infinity. So here instead of n factorial, so we have here n to the power of n multiplied by e to the power of negative n multiplied by the square root of 2n pi, then divided by n to the power of n, all raised to the power of 1 over n. Now you can see that we have some nice cancellations here. So n to the power of n and n to the power of n, right? So from here, we have limit as n is approaching infinity. So here we have e to the power of negative n, right? Then multiply by, here, square root of 2n pi. We can write it, if we recall this property, that the square root of m times n is same as m to the power of 1 over 2 multiplied by n to the power of 1 over 2, right? So from here, the square root of 2n pi, we can write it as 2n pi raised to the power of 1 over 2. Then all to the power of 1 over n. Now let us recall another nice algebraic identity. When we have a multiplied by b, then all of this is raised to the power of c. This is same as a to the power of c multiplied by b to the power of c. So from here, this implies that our limit equals limit as n is approaching infinity. So here, this is going to be e to the power of negative n, then raised to the power of 1 over n, right? Multiply by here. So this will become 2n pi to the power of 1 all over 2. Then raised to the power of 1 over n. So from here, this equals limit as n is approaching infinity. So you know here we have cancellation here. N times negative n times 1 over n will give us negative 1, right? So here we have e to the power of negative 1. Then multiply by here we have 2n pi raised to the power of 1 over 2 times 1 over n. This will give us 1 over 2n. So from here, this is equal to here e to the power of negative 1 is just a constant, right? So we can write it out. So we have e to the power of negative 1 limit as n is approaching infinity. So here we have to evaluate 2n pi raised to the power of 1 over 2n, right? Now we're going to make substitution here. We're going to let 2n equals k. Now from here, as n is approaching infinity, k is also approaching infinity, right? So from here, we have e to the power of negative 1 limit as k is approaching infinity. So here 2n is already k, right? So we have k pi, right? Then raised power of 1 over k, which we can still make use of this property once again. So we have e to the power of negative 1 limit as k is approaching infinity. So we have k to the power of 1 over k multiplied by pi to the power of 1 over k. So from here we have this e to the power of negative 1 times limit. So as k is approaching infinity, of k to the power of 1 over k multiplied by pi to the power of 1 over k. Now, if you recall vividly earlier that I told you guys that the reason why I dropped this right over here is because this is going to be very helpful in this video. The limit of x raised power of 1 over x as x tends to infinity is exactly equal to 1. And we have similar stuff here. The limit of this k to the power of 1 over k as k is approaching infinity, this is exactly equal to 1, right? And again, from here, pi to the power of 1 over k, recall that 1 over k as k is approaching infinity is 0. Then pi to the power of 0 is 1. So we also have 1 here. So this equals e to the power of negative 1 multiplied by 1 multiplied by 1, which is equal to e to the power of negative 1, which is exactly equal to 1 over e. And that's the right answer. So we can conclude that the limit as n is approaching infinity of n factorial divided by n to the power of n or to the power of 1 over n is equal to 1 over e. Amazing. Thank you for watching. Please kindly subscribe to my channel. Also like, comment and share. Bye bye.